Hi everyone, welcome to Dev 301, Production Grade Build Security for Developer Workflows. My name is Christopher Sanson. I'm a product manager at Google working on developer tooling. And with me is Anthony Bushong, a specialist customer engineer who will be joining us a little bit later to give a demo about some of the new features and concepts we'll be talking about. The increase in cyber and ransomware attacks over the last year, including high-profile cases such as SolarWinds, has been a wake-up call for the industry. Security is top of mind for companies large and small across all verticals. In May, the White House issued an executive order on improving the nation's cybersecurity in face of increasingly sophisticated and persistent threats to the public and private sectors. In this 20-minute talk, we're going to introduce some specific actions that you can take to create a more secure build environment on Google Cloud. Over the last 20 years, Google has built some of the most secure computing systems in the world, pioneering concepts such as zero trust. As part of GCP, we're bringing these internal best practices to our cloud customers through both open standards and integration in a variety of ways into GCP's managed services. In June of this year, we launched Open Source Insights, an exploratory visualization site for viewing the dependencies of open source projects. And in July, we announced SLSA, SLSA, an open framework based on internal Google best practices for formalizing the criteria around software supply chain integrity to help the industry and open source ecosystem secure the software development lifecycle. CI/CD is one of the most critical paths for securing your software supply chain. It's the gatekeeper by which code changes are released out to your users and has many entry points for vulnerabilities, pulling resources from a large number of internal and external sources while accepting contributions from hundreds or maybe even thousands of developers and other contributors at your company. In the SolarWinds breach that in part led to the White House executive order, it was actually a compromised build system that attackers used to inject malware into the candidate release that was ultimately published to downstream users. So in this talk, we're going to focus in on the build process specifically and talk about how to improve the security posture of your build environment. And we're going to do this by focusing on three main areas. One, network security. Two, build permissions. And three, binary authorization. So let's start with network security. One of the risks to an organization is data exfiltration at build time. Builds, by their nature, typically handle a large amount of private intellectual property across source code, databases, and artifact repositories. Now, naturally, we want to minimize the risk of any of this data egress to the public internet, whether it happens to be maliciously or just simply accidentally. The most common way that companies do this is by hosting resources inside their private network behind a firewall. Traditionally, this has meant then that you are self-hosting your own CI/CD solution. And besides just the additional overhead and total cost of ownership around developer velocity of having to install, manage, upgrade, and scale this system, it also means that you're responsible for securing it. And as we saw with the SolarWinds attack, bad actors can try to corrupt or attack the build system itself. In the case of SolarWinds, where at build time, when a file was fetched from the source repo, it was actually swapped out with malicious code and then sent to downstream users through the compile, build, and publish process. So let's take a different approach. Fully managed solutions like Google's Cloud Build offer a different tactic and are hosted and managed by Google Cloud running in Google's secure network, taking the burden off of you and your team for having to secure the system itself in terms of accessing the workers that builds run on. In June, Cloud Build launched Private Pools, a new feature which lets you securely connect a fully managed build system into your private network using VPC network peering. It supports private IPs on the worker, data regionalization, and static IP ranges for IP allow listing. Another common pattern with this firewall approach alone is that in many organizations, it's treated as sort of all or nothing. There's inside the firewall and outside the firewall. And once inside, you can access anything that is also inside the private network. Now, one of the best practices that we want to follow is that builds can access only what they need to and nothing more. So let's say, for example, that you have resources in multiple GCP projects that your build needs to access. How could we configure Cloud Build so that it can access these resources, but only these resources, and nothing else that would be sort of an attack vector? So this is where VPC Service Controls come in. With private pool support for VPC Service Controls, you can configure Cloud Build to restrict access more granularly to just the services that it needs to access. Additionally, you can use VPC Service Controls on the project that the worker pool itself is in to restrict egress, adding an additional layer of security against leakage of data to the public internet. Using private pool support for the GCP org policy, you can enforce that all builds are run on these approved worker pools that were successfully set up by your security team. So now we talked about network security. Let's move over to build permissions, where we have two main goals. Again, we want to grant builds only the permissions they need and nothing more. And second, we want to avoid the escalation of permissions from the build system to developers. We don't want developers to be able to access our production environments directly or decrypt production secrets that the build system needs, but developers shouldn't really have direct access to. So as an example, let's say we have two environments, staging and production. The first thing we're going to do is enforce that all changes go through our source repo or version control system, which then invokes the build automatically. This has a number of benefits, including change history, audit trails, CI tests, and using protected branches, we can enforce that only developers that have commit rights to the prod branch have the ability to invoke the production release pipeline. This lets us use pull requests to add a approval or manual review layer to all suggested changes from sort of developers that don't have permission to release directly to production. Likewise, we're going to want to make sure that the staging build doesn't have permissions to access our production environment either, which would allow another escalation of permissions to environments and secrets that should not be accessible from our staging pipeline. For that, we're going to take advantage of a new feature of Cloud Build for user-provided service accounts. In this instance, we're going to create two service accounts, one for our staging build and one for our production build, and grant them the respective permissions that they need so they can only access the resources that are needed at each of those environments. Next, we're going to use Cloud Build's integration with Secret Manager for managing the secrets. With Cloud Build's native Secret Manager integration, secrets are only decrypted at build time, and so not available in plain text in the build config or to developers. And because you're using Secret Manager, it's much easier and faster to rotate secrets frequently, further improving your security posture. The last thing we're going to do is add a manual approval step for the production pipeline. Using Cloud Build's approval features, we are going to make sure that an admin or other approved reviewer is able to manually review and approve all production deployments. And all of this is in the spirit of, again, preventing access from individual developers to production environments and other secrets that they should not be able to access directly, while enabling the build system to deploy to production. So now we've talked about build permissions as well. Let's move on to the last topic, which is binary authorization. So we've created our build pipeline that builds our container and deploys it out, in this particular case, Kubernetes Engine or Cloud Run, through our continuous delivery pipeline, whether that could be the newly announced Cloud Deploy, an open source solution like Spinnaker, or even Cloud Build itself. But how do we enforce that only approved builds are deployed to our runtime environments? What's stopping a bad or unauthorized actor from building their own image and then deploying that out directly or injecting it into our CD pipeline? For this, we're going to leverage binary authorization from GCP, which lets you define deployment policies for which containers can and can't be deployed. So in this case, let's create a policy that says only containers built by Cloud Build can be deployed out to GKE or Cloud Run. This will ensure that any unsigned images or images signed by an untrusted build system will fail our policy check and not get deployed out to our production users, whether trying to be deployed directly or through our CD pipeline. Lastly, Cloud Build will create and sign an attestation for each image that it builds, saying that it was built by Cloud Build, allowing it to pass the binary authorization verification process and get deployed out to our environment. So we talked quickly about Cloud Build and how you can use Cloud Build to improve your security posture to create a more secure build environment, while at the same time improving developer productivity and reducing operational overhead altogether. So we talked about some of the features that were newly launched in 2021, including private pools, user-provided service accounts, secret manager integration, manual approvals, and better support for binary authorization. Now let's hand it off to Anthony for a demo of some of what we discussed. Anthony?
Thanks, Christopher. Let's dive into how we can put these principles into practice. Let's start by taking a look at our Cloud Run application. In this case, we're utilizing a containerized Python Flask web app that's accessible at this URL, and it's only accessible by authorized users, so we'll provide a token when issuing a request, and you'll see that we get a HTML page in response to our request. Our Cloud Run application actually has binary authorization enabled. As a reminder, binary authorization is the ability to only admit a certain set of container images to your runtime environment like Cloud Run or GKE. In this case, we've configured binary authorization to only approve images that have been signed by the Cloud Run attester. In this case, the Cloud Run attester is only signing images that have been built with Google Cloud Build. We can see binary authorization in action if we try to deploy an image to the Cloud Run service that was not signed by our attester. So in this case, for our Next 2021 app, you'll see here that I have a container image that's tagged rogue, and this was built out of band, not utilizing Google Cloud Build. And if I was trying to deploy this container image to Cloud Run, we should actually see our binary authorization policy in action by denying that container image to be deployed to Cloud Run. Now that we've demonstrated how we can handle images that we don't trust, let's take a look at the automation that Cloud Build provides and how we can build images that we do trust. To build our container image, what we're actually utilizing are Google Cloud Build's support for triggers. Both of these triggers are connected to my GitHub repository titled Next 2021, which actually has our application code. The first trigger kicks off builds automatically based on any changes to a feature branch. In this case, it'll run builds that build a container image, signs a container image, and will actually open up a pull request against the main branch in the GitHub repository. The second trigger actually kicks off and deploys the container image to Cloud Run based on any changes made to the main branch. One of the things we want to consider here is the ability to apply the principle of least privilege, and in this case we're actually able to do this by separating the service accounts that each of these triggers utilize. You can see here for the first trigger, we're utilizing a service account that is titled Build Next 2021, and this has permissions to the container registry and things like that that actually help it to perform the build that it needs to run. And then the second service account is called Deploy Next 2021, which has permissions to deploy to Cloud Run. While in this example I'm utilizing a github.com repository, it is important to call out that Google Cloud Build also has support for self-hosted source code management systems like GitHub Enterprise. So you can actually see here that in Cloud Build, I actually have a host connection to a private GitHub Enterprise server that I also utilize in Google Cloud. And you can see that I've actually made connections to various repositories in that GitHub Enterprise instance. This means that I can also create Cloud Build triggers on these private self-hosted repositories. Now let's take a look at the actual build that our first trigger is running. This trigger is looking in the build folder, and the first trigger specifically is looking at the build.yaml specification for Google Cloud Build. Our first build step is building our container image that will end up running in Cloud Run, and we're actually publishing that to Google Container Registry. And you can see here that we're utilizing Cloud Native build packs to automatically generate that container image. Once we've signed the container image, our final build step actually will open up a pull request against our GitHub repository. And you can see here that the way that we're able to do this is that we're utilizing the GitHub API. And in order to authorize ourselves or the build to be able to perform this action, we're providing a GitHub token. And so one of the critical components of a secure build environment is careful secret management. In this case, Google Cloud Build allows us to natively access secrets stored in Google Cloud Secret Manager. So you can see in this scenario, we're actually storing our token, our GitHub token, in Secret Manager and providing that back to the build itself as an environment variable. This means that we are not providing static credentials to our actual build or codifying that into our build container images, but rather these are dynamically accessed utilizing the service account, which is provided to the build. If we jump over to Google Cloud Secret Manager, we'll see our secret, our GitHub token, and we'll see here under permissions that we've actually granted secret accessor permissions to our Build Next 2021 service account, which is being utilized by Google Cloud Build. And the important thing to note is that this is a granular permission. It is not for all secrets that are stored in Secret Manager, but rather on a per secret access basis. The next important field to call our attention to in the Cloud Build specification is under Options Worker Pool. This actually allows for us to specify on a per build basis whether or not a build should run in a Cloud Build private pool. So what is a Cloud Build private pool? Well, private pools extend the user configurability for the workers that actually run a user's build. So in this case, we can specify additional things like regions. We can also specify and have access to more machine types. And perhaps most importantly, we have private VPC connectivity to access private resources either within our own network in Google Cloud or within a data center that is connected to our Google Cloud VPC. So you can see here that I've specified for Sandbox Private Pool to have connectivity to Sandbox VPC Private Pools, which is actually running the GitHub Enterprise server that I was showing earlier in this demonstration. Not only do we get private VPC connectivity with Cloud Build Private Pools, but we actually have the ability to remove external IPs from our workers altogether, and in general can now consider how we can use VPC Service Controls to secure our build perimeter running in private pools. So now let's actually trigger this first build that'll run on a private pool. So I'm going to change the web application and just add a couple of small, very minor changes by adding a couple exclamation points in some of the HTML. And I'm going to commit this to development branch. And then what we're going to want to do is create a feature branch that will kick off our trigger now that we're done with the development branch. And as you can see, our build is now queued to run in US West 1 on a private pool. And if we actually dig into the build, we can see our build steps, which builds a container image, attests the container image, or signs the container image, and then creates that GitHub pull request. And after a short amount of time, we can see that our build has completed, the final step being the pull request being created. So if we actually jump over to the repository, we can actually see the PR from feature against main. And so we can review that. We can see that our build is completed, and now we can utilize Git as an opportunity to basically gate the next build, because we have the opportunity to either approve and merge these changes, or we can close the PR. So in this case, once we click on merge, we're actually going to kick off the second trigger, which will deploy the service to Cloud Run. So we're going to click that. And that branch has now been successfully merged. So if we quickly glance at the build that is going to run, we can see here that it's a single step, and we're just using gcloud as our build step, and we are passing in the arguments to basically deploy to Cloud Run our latest image that we've built. Now let's take a look at our last build from the second trigger that will deploy our new container image to Google Cloud Run. One of the things to consider is that many teams will often introduce a manual approval stage for pipelines that deploy to a production environment. And this basically allows for an operator or developer to have that final decision to actually promote an image into a production environment. So as you can see, Google Cloud Build has actually introduced the notion of manual approvals. So we can see that the trigger has created our build. However, the build has not begun to execute to actually deploy to Cloud Run because we have not yet approved it. So once we click off and approve, we may have the ability to provide context on perhaps monitoring or certain documentation or a ticket that actually captures whatever metrics or heuristics that allow us to promote this production. And we can click approve, and our build will actually begin to kick off and run. And after a short period of time, we'll see that our single step build has completed, and we have now deployed the new container image to Cloud Run. So let's take a look at Cloud Run. And we can actually see that we have a new revision. This was the failed revision that was not signed by the attester in Google Cloud Build. So it failed to deploy due to binary authorization. But because we built this image with Cloud Build and it was actually properly signed by the Cloud Run attester that we had, It is now successfully deployed. And once we issue that request again to our application, we can see our changes with the additional exclamation points. We demonstrated how we can secure our build environments with granular build permissions, a secure network perimeter, manual approvals, and admission control to targets like Cloud Run and GKE. Back to you, Christopher.
Thanks, Anthony. That was a great demo. Now, of course, what we just covered today was really meant as an introduction and a high-level overview of some of the specific actions you can take to secure part of your larger end-to-end ecosystem. If you're interested in learning more, here are some additional talks here at Next around securing your software supply chain that we highly recommend you check out as well. Thank you for your time, and we're happy to take any questions.